Good morning, dear students. My name is Ferhan Mazher, and today is 24th of April 2022. Right now, I am with the 11 Cambridge class, and the subject we are studying is Physics 5054. This is Cambridge O Levels Physics, and the code of the subject is 5054. Today, we have set our hearts to solve a theory paper, and we have selected October November 2011 2 paper. This paper 2 belongs from the zone 2, or you can say variant 2. In this session, in this video, we are going to solve the section A of this paper. The section B of this paper we will solve in another video, and soon I will upload that video. So let's start today's paper, and on your screen here comes the question paper. October November 2011 2 paper. Paper 2 we call it, 1 hour 45 minutes. Section A we are going to attempt. So the first question coming up on your screen. Answer all the questions in this section, answer in the space provided. A builder needs to determine the density of a solid cube of wood. He places the 50 centimeter mark of a uniform meter rule on a pivot so that the rule balances. He then places the cube on the rule with its center of gravity directly above 75 centimeter mark. A mass of 0.050 kg is moved along the rule until balance is restored. This is shown in the figure 1.1. So here we have a rod, and in the center of the rod we have put a pivot. Here we have put a cube which is at 75 centimeter mark. The pivot is at 50 centimeter mark. The distance between them will be 25 centimeter. Here we have placed, you can say we have placed a mass, and its mass we know is 0.050 kg, and it is at the mark of 10 centimeter. And you know its distance from the pivot is this distance, and this distance is 40 because this is 50, this is 10. So the distance between them will be 40 centimeter, and this whole thing is in balance. The rule is balanced when the 0.050 kg mass is at the 10 centimeter mark. Calculate the mass of the cube. Okay, so the mass of this cube we can find very easily. You know, this mass is trying to produce, this weight is trying to produce a anti-clockwise moment, and this is trying to produce a clockwise moment. Because the rod is balanced, so that means that these two their moments are equal. Clockwise moment, anti-clockwise moment, anti-clockwise and clockwise moments, they are equal to each other. So we will apply that formula, and let me show you. Here we go. So the anti-clockwise moment will be equals to the clockwise moment. W1 D1 equals to W2 D2. So the weight one, the mass into the G value, the W is equals to mg, you know that. So 0.050 into 10 into 40 centimeter equals to W2. We want to find out 25 centimeter. So that 40 centimeter, the mass 0.050 kg was 40 centimeter to the left of the pivot, and the W2, that was 25 centimeter to the right of the pivot. So the W2, if you make the W2 alone on one side, it will be 0.050 multiplied 10 multiplied 40 divided by 25, and that will give you 0.8 Newton. So the weight of that cube is 0.8 Newton, but the question is not the weight. They want you to find out the mass. So W2 is equals to mg. So m will be equals to weight divided by the g value. So 0.8 divided by 10, and it will be 0.08 kg. I hope you understand this numerical 0.08 kg. So let's check from the marking scheme. 0.08 kg is the right answer, sir. Hopefully you understand. The cube has a volume of 1.6 expo minus 4 meter cube. Determine the density of the wood. You know, the formula for the density is mass divided by volume. In the A part, we have found the mass of that cube, and now we know the volume also, so we can find the density. Density is equals to mass divided by volume. So very easily we can find out density is equals to mass divided by volume. So mass is 0.08 kg, and the volume is 1.6 expo minus 4 meter cube. So when you enter this value into your calculator, in the calculator, you will write 0.08 divide 1.6 expo minus 4 equal, and that will give you 500 kg per meter cube. Hopefully you understand. 500 kg per meter cube. So our answer is right. Okay, so we are done with the question number 1. So we are going to the next question. The next question is question number 2. Figure 2.1 shows a skier of the mass 85 kg skiing down a very steep slope. So here we have the skier. It's going down on a very steep slope, and from B, this thing becomes horizontal, and it traveled 33 meter on the horizontal portion of that path. The skier starts from rest at the top T of the slope. The force of gravity accelerates him down the slope. When he reaches the bottom B of the slope, his kinetic energy is 5.5 expo 4 joules. The gravitational field strength is 10 Newton per kg. Calculate the weight of the skier. We know the mass of the skier. The mass of the skier is 85 kg. So very easily we can find the weight of the skier. The weight of the skier, W is equals to mg, and we know the g is 10. So the weight of the skier will be W equals to mg. So 85 kg multiplied 10 Newton per kg. So 850 Newton. So it will be 850 Newton. So let's have a look at the marking scheme. 850 Newton is the right answer, sir. Okay, so then once we know the mass, then weight, sorry, the minimum possible difference in height between the T and the B. So T and the B, so the minimum height is this one. We're talking about the vertical height. So the idea is that whatever is the gravitational potential energy here, and whatever is the gravitational potential energy here, the decrease in the gravitational potential energy will be equals to the gain in the kinetic energy at the point B. So remember this. The loss in the gravitational potential energy is equals to the gain in the kinetic energy, and the kinetic energy gain is given here, 5.5 expo 4 joules. So let's work on this idea. So the loss in the gravitational potential energy will be equals to the gain in the kinetic energy, and the kinetic energy we know is 5.5 expo 4. And you know the loss in the gravitational potential energy will be mgh. M is 85, g is 10, and h is the fall in the vertical height from T to B. So that will be equals to 5.5 expo 4. So when you make h alone, it will become 5.5 expo 4 divided by 850, and that will give you 64.7 meter. So when I round it off to two significant figures, it will be 85 meters. So our answer is 85 meter. Sorry, I said 85, it's 65. 65, let me show you again. It's 65. So the marking scheme says 65 or 64.7 meters. So our answers are right. Okay. Then at B, the skier digs his skis into the snow and stops at the point P after traveling 33 meters horizontally. Calculate the average horizontal force that's act on the skier. You see, you have to make the kinetic energy 0. When you stop, whatever was your kinetic energy, you have to make it 0. So the work done is equals to the change in the kinetic energy. Kinetic energy from 5.5, the kinetic energy was 5.5 expo 4 joules, and you have to make it 0. So you stop, and so you stop. So the change in the kinetic energy will be from 5.4 expo 4 joules to 0 joules, and that will be equals to the work done against the friction. And so very easily I can, and you know the work done is also force into distance. So the force into distance, the work done can be found by two ways. One is change in the kinetic energy. The other way is F into D, where D is the distance traveled against the friction. So I will make them equal, and from there I can calculate how much is the distance traveled. So F into D is equals to the change in the kinetic energy. So D is 33, and I need to find out how much is the force. So F will be equals to 5.5 x per 4 divided by 33, and it will be 1666.67. So if you round it off to two significant figures, it will be 1700 Newton. So our answer is 1700 Newton, or you can say 1666. So let's check. So our answers are right. Hopefully you understand this idea that when you apply brakes, the work done against the friction is equals to the change in the kinetic energy. The initial kinetic energy was 5.5 x per 4 joules, and the final kinetic energy is 0. So the change in the kinetic energy is 5.5 x per 4. Hopefully you understand this idea. So we are going to the next question. The next question is question number 3. Here we have a helium balloon carries scientific instruments high up in the atmosphere. Figure 3.1 shows the partially inflated helium balloon leaving the ground. So this is the helium. It's filled with the helium and it will go into the air. Okay, a completely deflated balloon containing no gas. The helium to inflate it is stored in a very large cylinder at a pressure P1 of 2.5 x per 7 Pascal. Helium that occupies a volume V1 of 18 meter cube in the cylinder is slowly released into the balloon until the pressure P2 in the balloon is 1 x per 5 Pascal. The temperature of the helium remains constant. State the equation that relates the volume V2 of the helium in the balloon at the launch to P1, P2, and V1. If the temperature of the gas do not change and the volume will change, the gas volume change, and obviously the pressure will change, the temperature is constant. For the gases, we use the law, we call it P1, the equation is P1, V1 equals to P2, V2. So the equation will be P1, V1 equals to P2, V2. The next part is calculate the V2. The pressure one So, my dear students, if you want to calculate what is the value of the V2, you see the V1 is 18 meter cube, the P1 is 2.5 x per 7 Pascal, and the P2 is 1 x per 5 Pascal, and the V2 is the question. We will use that relationship P1 V1 equals to P2 V2, and from there I can calculate what is the value of the V2. So here we go. So the P1 V1 equals to P2 V2, 2.5 x per 7 into 18 equals to 1 x per 5 into V2. So when you make V2 alone, it will become 2.5 x per 7 into 18 divided by 1 x per 5, and that will be 4,500 meter cube. So the V2 value will be 4,500 meter cube. So let's check the marking scheme. What the marking scheme says, 4,500 meter cube is the right answer, sir. So let's move to the next part. The next part coming up on your screen. He says when it leaves the ground, the balloon is only partially inflated. Suggest and explain why this is necessary. You see, whenever we send the balloon into air and it's partially inflated, the reason is that as the balloon will go higher, the atmospheric pressure will decrease. So due to the external pressure, the atmospheric pressure, when it will decrease, the gas which is in the balloon, its pressure will still be the same. But the atmospheric pressure, which is trying to squeeze that gas, that will decrease. So due to this, what will happen? The balloon will automatically starts inflating. So if you have already inflated it fully, so when it will go into the higher altitude, there it will burst. To avoid that, we do this. I hope you understand what I'm saying. Okay, so balloon inflate as it goes to higher altitude, because at higher altitude the atmospheric pressure decreases. Chances are it might burst if already inflated fully? So I hope you understand this answer. So let's have a look at the marking scheme. Balloon inflates higher up, burst if fully inflated on the ground. Atmospheric pressure is less. Higher up decreases with the height, or otherwise greater outthrust upwards force, otherwise rises too high fast. So I think you understand what is the answer. Okay, so let's go to the next question. This is question number 4 coming up on your screen, and the question number 4 is figure 4.1 represents a microwave traveling in air through point A and B. The distance between A and B is 40 centimeters. So you can see this is a wave, a transverse wave, microwave. So how many waves are there? One wave, two wave, and half, 2.5 waves. And the distance between A and B is 40 centimeters. So in 40 centimeters, there are 2.5 waves. C says state the speed of the microwave in the air. The speed of the microwave in all the transverse waves in air travel with the speed of the light. So it will be 3 expo 8 meter per second. So it will be 3 expo 8 meter per second. So let's go to the next part. He said determine the wavelength of the microwave shown in the figure. So in a distance of 40 centimeters, there are 2.5 waves. So the wavelength, one wave will be of 40 centimeter divided by 2.5. So that will be 16 centimeters. So the wavelength will be 16 centimeters. So let's have a look at the marking scheme. What the marking scheme says. Okay, so this is the first answer. This is the second answer, 16 centimeter. Okay, so let's go to the next part. He says describe how microwaves are used in the transmission of the television signals. By the satellites, you see we use microwaves, and the television station will send the signal in the form of the microwaves, and the satellite in the space will receive that signal, and it will boost it, it will amplify this signal, and it will resend this towards the earth. On the earth, the people who are using the satellite television, they have a satellite dish on their roof, and they have a decoder, and the dish receives that signal, and decoders decode that signal, and on the television you can see the television programs coming from the satellite. So let me show you my written answer. It says from television station, signals are sent to the satellite in form of microwaves. Satellite boosts them and send back the signal to Earth. On the ground, satellite dish and decoder receives this signal. So let's have a look at the marking scheme. What the marking scheme says. He says any three of the travel through the space and the vacuum. The microwaves, they can travel through the space and vacuum, pass through the atmosphere, not reflected by the ionosphere, encoded with the signal. Satellite amplifies, boost the signal, sent to received by satellite, transmitted, sent by satellite, transmitted, received by a satellite dish on Earth. So you only have to write three of them. We have written them. So hopefully you understand this. Okay, so the next question coming up on your screen. He says, state two properties common to all electromagnetic waves. All the electromagnetic waves, remember, they are transverse waves. All the magnetic waves travel with the speed of the light. All the electromagnetic waves can travel through the space. They do not require medium for their travel. So all of the electromagnetic waves obey V equals to F lambda, wave equation. Okay. So I have written only two of them. They all are transverse wave. That's one property. They do not need medium for their propagation. For their travel, they do not require medium. So let's have a look at the marking scheme. Marking scheme says any two of same high speed in air or travel at the speed of light, travel in vacuum space or no medium needed, transfer or transmit energy, transverse stated or explained, oscillating magnetic and electric field waves, reflection, refraction, diffraction, interference, polarization. So these all are the characteristics of these waves. So we are going to the next question. The next question coming up on your screen is question number 5. It says figure 5.1 shows part of an electric bell. Okay, so this is the part of electric bell. Here is iron core, which has a wire wound on it, and that is connected with a battery and a switch. Here is an iron bar. A switch and a cell are in series with the length of a wire coiled around an iron core. The switch is closed and the current in the wire produces a south pole and a north pole at the ends of the core as shown in the figure 5.1. You can see north is here, south is here, because when the current will flow through this coil, this will become an electromagnet. So at the ends of the core, as shown in the figure 5.1, magnetic poles are also produced in a small iron bar placed near to the ends of the cores. Due to this magnet, and by the process of magnetic induction, this iron bar will also become magnet. Okay. So on the figure 5.1, marked with a north and the position of the north pole produced in the iron bar, and marked with a S, the position of the south pole produced in the iron bar. So opposite to this north here, you will have a south, and opposite to this south, you will have a north here. So let me show you, I have done this. Hopefully you can see that. Okay. So let's move to the next part. North at the top bar and south at the bottom. Okay, so we are done with this. Okay, he says state and explain what happens to the iron bar once it's magnetized. So once it's magnetized, it will be obviously attracted to this iron core. This iron bar, because south will be here, north will be here, it will be attracted to this iron core because they have the opposite poles on their ends which are facing each other. It will be attracted to the iron core. Iron bar is attracted to the iron south of to the what I have written. Iron bar is attracted to the south and north end of the iron core respectively. Okay. So the iron bar is attracted to the south and the north of the iron core. Basically, you have to write here, these sentences have become weird, but you have to write that the south of the iron bar is attracted to the north of the iron core, and the north of the iron bar is attracted to the south of the iron core. And the opposite poles, they attract each other. So it will be basically attracted. Let me show you my answer. I wrote the little weird answer. Attracted to move towards the iron core, unlike poles attract. So here we go. He says the switch is opened and there is no current in the wire. State what happens to the magnetic poles in the iron bar. So when you will open the switch, there will be no current in the wire. So the iron core will be no more electromagnet. When it will lose its magnetism, the iron bar will also lose its magnetism. So it will be no more attracted. So the iron bar will be demagnetized. There will be no poles on the ends of the iron bar, and it will be no more attracted. He said they disappear, bar is demagnetized, loses power, is weaker. Okay, so our answers are right. So you can see the question number 5 coming up on the screen. Okay, the answers of the question number 5. So here we have an electric engineer measures the potential difference across the length of a metal wire and the current in the wire. He does this for different values of the current. Draw a labeled circuit diagram of a circuit that enables the engineer to do this. So let me show you. So here you can see I have used a battery, and with the battery I have put an arrow here, which means that this power supply, the voltage of this power supply I can change. Here I have put an ammeter, here's a switch, here is a fixed resistor, and here I have put that wire, and I have put a voltmeter parallel to that wire. Power supply, wire, resistor, bulb, and ammeter in series, voltmeter across wire, resistor, bulb labeled clear. A variable power supply or rheostat in series or potentiometer, correct symbols or labeled throughout. Okay. So what is the question? Describe how the circuit is used. So what we will do. I will keep the voltage minimum. I will close the switch. I will note down what is the reading on the ammeter. I will note down what is the reading on the voltmeter. Then I will open the switch. Then I will increase the voltage of the battery, and then I will close the switch. I will note down what is the reading on the ammeter. I will note down what is the reading on the voltmeter. So here we go. Close the switch and note reading on the ammeter and the voltmeter. Switch off the circuit, increase the voltage of the battery. Close the switch and note the readings on both the meters. Then their question is, what's the question? State the equation that defines the resistance. The resistance is the ratio of the voltage and the current across a resistor. So R is equals to V by I. Famous. Let me show you. So you can see the answers are right. Okay, so let's move to the next part. The engineers perform the experiment and notices that the potential difference across the wire is directly proportional to the current in it. He calculates the resistance of the wire and plots a graph of the resistance against the current. So you see the potential difference is directly proportional to the current. That means that this wire is obeying the Ohm's law. If something obeys the Ohm's law, if the voltage and the current, they are directly proportional to each other, it obeys the Ohm's law. We call it ohmic conductor, and its resistance do not change. So when you have to draw a graph between the resistance and the current for that wire, it will be a horizontal line, which means that you decrease the current, increase the current, the resistance will not change. It will remain constant. So let me show you. So it will be a horizontal line. Hopefully you understand. So it will be a horizontal line above the x-axis. So our answers are right. So let's move to the next question. It says the current in the transmission line used to supply electric power to the village is 65 ampere. The power is transmitted at a voltage of 23,000 volt. Calculate the power supplied to the village. The power is, the formula for the electric power is IV. Power is equals to IV. So 65 ampere multiplied 23,000 volt, and if the power will be 1495000 watt, approximately 1.5 x per 6 watt. So let's check the markings here. Where is that? Yeah, 1.5, 1.49 x per 6 watt, or 1.5 x per 6 watt. The transmission, he says the transmission line has a resistance of 3 ohm. Calculate the potential difference across a 3 ohm resistor that carries a current of 65 ampere. According to Ohm's law, V equals to IR. So V is equals to IR. I is given, R is given, you can calculate the voltage drop. So V is equals to IR, 65 multiply 3, so 195 volt. So the voltage drop will be 195 volt. Let's check. 195 volt is the right answer, sir. Okay. Then he says thermal energy heat produced in 1 second in a 3 ohm resistor that carries a current of 65 ampere. So we have to calculate the energy. You know, the energy is equals to power multiplied time, and the power loss in the form of heat is I square R into T. So 65 square multiply 3 multiply 1 second. So it will be 12675. When you round it off, it will be 1.3 x per 4 joules. So our answer is right. Okay, so let's move to the next part. He says, state one advantage of transmitting the electric power at a high voltage. You see, by the help of the step-up transformer, we increase the voltage, and when we use a step-up transformer and the voltage is increased, the current decreases. And in the transmission lines, the power loss is given by the formula P is equals to I square R. If the value of the I will decrease, the power loss in the transmission line will also decrease. So why we increase the voltage? The reason is to decrease the power loss in the transmission lines. At high voltage, the current becomes low. This reduces the power loss in the transmission lines. So let's have a look. Low current, less energy, power wasted, less heat generated, less voltage loss, more efficient, thinner wires. So when the current will be less, you will need thinner wires. So that's one reason why the main power supply to the houses in the village is at a voltage much lower than 23,000 volt. You see, 23,000 volt is a very high voltage and it is very dangerous. So you cannot bring this voltage in a house. So when you bring the electricity to household, you reduce the voltage, for example, to 220 volt in Pakistan by using the step down transformer, because 220 volt will be safe, and the insulation on the wires at this voltage, they will not, normally they will not melt. When the voltage is reduced, the electricity will be more safe for household usage. My answer, let's check a market scheme. Step down transformer, between them or less insulation needed, or insulation on the wires. Okay, so when the voltage is low, the insulation required is less. Less dangerous, or less chance of electric shock, or less danger for sparking. So let's move to the next question. He says figure 8.1 shows a short-sighted eye. Okay, the short-sighted eye means the person can see the near objects, but the far objects it cannot see clearly. Rays of the light from a distant star are parallel as they reach the lens of the eye. Refraction of the light as it enters the eye has been ignored in the figure 8.1. Figure 8.1 continue the ray to show their path inside the short-sighted eye until they strike the retina. You see, in the short-sighted person's eye, the light rays, they cross each other before the retina. They make the image before the retina instead of making the image on the retina. So let me show you. So you can see, instead of making this crossing here on the retina, they make it before the retina. So the image is formed here. So if it is not formed on the retina, so you will not be able to see it clearly. Explain how your diagram shows that the image of the star seen by the observer is blurred. The image is blurred because the image is not formed on the retina. The image is formed before the retina. So obviously you will see a blurred image. Image is formed in front of the retina instead of being formed on the retina. Okay, so our answer is right. So the next question coming up on your screen, he says, figure 8.2 shows three parallel rays of the light on the line P in the figure 8.2. Draw the shape of the lens that you use to correct the short-sighted. To correct the short-sighted, we use the concave lens. So we have to draw a concave lens here. Then he says on the figure 8.2, continue the three rays through the lens that you have drawn. Okay, so let me show you. So here you can see I have drawn a concave lens. This is a diverging lens. So this light ray which passes through the optical center will go undeviated. Here is the F. I've just supposed the F is here. So this ray will be diverged and it will appear that it's coming from here. And this ray will diverge and it feels that it is coming from this point. So this is because this is a diverging lens. So my dear students, so we are done with this. Let me show you. Always diverge. Okay. So the next section is section B. The section B we will do in another video, in another session. So, my dear students, today we have solved October-November 2011 Physics 505422 paper. In this video, in this session, we have done the section A of this paper. The section B of this paper we will solve in another video, and soon I will upload that. So thank you very much, everyone, for being patient and watching this video. If you're watching this video and if you think that this video has helped you to practice the physics paper and it has helped you to learn the concept, please subscribe my channel. Also like this video. If you have any comment, please feel free to comment. Share the link of this video onto your Facebook accounts and onto your Instagram accounts and onto your Twitter accounts. Share the link of this video with your junior students, with your teachers, with your other fellows who are in Cambridge O-levels. It's a great blessing for me to be teaching you online and being helpful to so many people. Keep praying for me. Thank you very much. Have a good day. God bless you all.